In this video, we're going to discuss some switching fundamentals. And essentially, we're just going to go over some of the basic concepts and basic definitions that you'll need to understand switching in general. Now, obviously, this is not an exhaustive list of every definition to do with switching. This is just the things you'll need to know to understand what we're going to discuss in future portions of this course. And some of this will be very basic, but as I mentioned at the outset of this course, I'm not assuming you know anything about networking, because that's what the CCNA certification is aimed at, someone who wants to get into networking. So, all that said, let's start at the beginning. First off, a hub or a repeater. It is a dumb layer 1 device that regenerates every received electrical impulse out of every other port except the one it was received on. So essentially, it takes an RJ45 network or a star-type topology and makes a big shared media topology out of it. Now, collisions are very common on shared media networks because, again, this hub or repeater will not actually examine the frames to see where they need to go. It receives electrical impulses on port 1 and echoes it out ports 2 through 8. And you'll recall from the Ethernet fundamentals that a collision is when two devices attempt to talk at the same time. If it receives electrical impulses on port 1 and port 3 at the same time, then the signals from those two ports will collide inside the hub and generally slow down the networking speed. Now, we'll see a way to get around that here in just a second. A switch is a layer 2 or higher device that connects multiple devices similar to a hub. If you were to take a hub and a switch and set them side by side, they would look exactly the same. They would have RJ45 ports on the front, they would have little light indicators indicating traffic and connection state, but otherwise wouldn't look different except one will say hub and one will say switch on it. Now again, Ethernet switches can operate at multiple layers. For the purposes of the CCNA, we're only going to discuss layer 2 switches. If you go on to the CCNA and the CCNP and up to the CCIE, if you go that far, you'll deal with layer 2, layer 3, layer 4, all the way up to layer 7 switches. Now the magic sauce inside a switch, if you will, is that a switch maintains a MAC table. It watches all the traffic that comes in and says, well, I see this MAC address on port 2, and I see this MAC address on port 3, and I see these 5 MAC addresses on port 5. It then uses that MAC table to send the Ethernet frames only to the end stations that they are destined for. I've got a nice little visual diagram of how this works in a later video in this course when we discuss switching in depth and exactly how it maintains this MAC table. But at the very fundamental level, a switch is a layer 2 device that actually inspects the Ethernet frames as they come across at the data link layer, at layer 2, and can therefore determine exactly where those frames need to go, whether they need to go out of all ports if it's a broadcast, or whether it needs to go out a specific port or a specific set of ports if it's a multicast or a unicast. And again, we'll get into all of that when we talk about IP, because I'm really using IP terms here. So now you know the difference between a hub and a switch. Let's talk about two other concepts that will become very important in future discussions of Ethernet networking. The first is a collision domain, and a collision domain is a segment of the network where Ethernet frames can collide with one another. You remember back to our discussion of a hub, every device plugged into that hub is on the same collision domain. Collision detection is the CD portion of CSMA-CD. You remember carrier sense, multiple access collision detection. The collision domain is where that collision detection algorithm works. Obviously, collision domains are only an issue with hubs or repeaters. If you have a switch and the switch knows where the frame is supposed to go, then only one workstation will talk on that particular port at a given time, and therefore you don't have any collisions. The other concept that's important to remember is the broadcast domain. The broadcast domain is a segment of the network where broadcasts can reach all nodes on that network. Now, generally speaking, a broadcast domain is the same layer 3 network, the same range of IP addresses or IPX addresses or whatever layer 3 protocol you happen to be running. Now, the magic sauce, to reuse my term, in a switch is that a switch maintains one large broadcast domain, but splits the collision domain up, basically one collision domain per port. So essentially, all of the machines on a given switch or a given VLAN, and again we'll talk about VLANs elsewhere in the course, are all in one broadcast domain. But unless you have a hub plugged into a switch port, each workstation or each network device is on its own collision domain because the switch knows this MAC address is the only thing connected to this particular port, so therefore this is the only traffic I'm going to send out that port. Therefore, there's no chance for collisions because there's only one workstation or a small number of workstations that could ever talk on that segment at any given time. And so therefore, you can have a greater number of switches in the same broadcast domain because they're all on separate collision domains. Whereas the more hubs you put together, the more repeaters you plug together, will very quickly degrade the performance of the network because they're all on the same collision domain. It's just like people in a big bus. The more people you put in a bus and everyone's talking, the louder it gets, the less chance it is that you're actually going to get the message to the person on the other end of the bus without having to resend it and retry multiple times. And that's the difference between the collision domain and the broadcast domain. The collision domain is everybody talking on the bus all at the same time, i.e. they're talking on a hub. If they're split off into multiple individual collision domains, it's like everybody on the bus has a walkie-talkie and everybody can talk to everybody else, and you don't have to worry about those conversations colliding in midstream. And that covers our discussion of switching fundamentals.